We learned about interfaces being revved up in our earlier session with fully implemented methods called as static and default methods. In this lesson, we are going to learn about multiple inheritance of these interface methods. In Java, we can inherit from a single class, but we can implement multiple interfaces. As interfaces were never had implementations, there was no problem with multiple inheritance in the first place. However, with Java 8, we have concrete implementations in an interface itself. So, does it mean if a class implements multiple interfaces, which may have full-blown implementations, is suddenly embracing multiple inheritance strategy? We know the multiple inheritance of state is evil, and hence no place in Java since its beginnings. The dreaded diamond problem has been out of picture in Java from day one. Since Java 8 unlocked the interfaces, there are at times we may have defined same default method implementations in multiple interfaces. So in this case, isn't it our subclass implementation implementing those multiple interfaces inherit the methods and thus allowing the multiple inheritance evil back in? Well, not exactly. The multiple inheritance of behavior is what being inherited, but not state. The interfaces will only allow the functionality being distributed or inherited by others, but not state. So in this session, we will run through some multiple inheritance strategies as well as some of the examples and the rules governing the multiple inheritance because of the Java 8's unlocking of interfaces. Let's run through some multiple inheritance examples. Say we have an engine interface with one default method. This engine interface has got single method model, which when given an ID returns default engine as its output. Let's implement a car which implements this engine interface. Let's say there's a method called getModel. This getModel is implicitly calling a model method, which is the default method defined in the interface engine. So far, there is no surprise. Everything is in order. Let's introduce another interface called vehicle with exactly the same default method. We simply cut and paste the method name here. So we got exactly identical interfaces with the same default methods, the engine and the vehicle. Looking at the engine and the vehicle interfaces, we know that both are implementing the same method as defaults. What happens to car if we implement vehicle 2 in addition to engine? So let's modify our car to implement vehicle interface as well. As you can see, immediately car complains. It says duplicate default methods from engine and vehicle are detected. So the compiler isn't happy at all. What it is telling us is that we got two duplicate methods found in these two interfaces. What's happening is that compiler is trying to resolve the method from the interfaces, but unfortunately because both of the interfaces has got exactly the same method, is unable to find out who has got the precedence over the other. In such situations, it is us developers who should be dictating a direction. We need to follow 3 simple rules that will be issued to resolve such issues. So, we use rule number 1 to resolve this issue. What is rule number 1? It says, in such scenarios, a class must declare its intention explicitly by overriding the default methods. That is, classes always wins. Compiler will always pick the class method. So our car, should it has defined the same method, compiler picks it up straight away and the problem is solved. So let's see what happens if we declare the same method in car. As you can see, we now declared the same implementation in our class and compiler is really happy now. So rule number 1 says that if the class has got the same method, it is going to win over any other interface default methods. There's also one more thing I want to mention here. Let's suppose if we want to pick up the model method from engine interface, how can we do that in car? Can you see that we are using a super implementation of the interface? This is the enhancement of the super keyword in an interface. Now let's see the rule number 2. What happens if our vehicle extends engine interface. So what it means is that we have engine and we have vehicle extending engine, and our car class implements both engine and vehicle interfaces. Does it complain? No. This is because of a second rule. Sub-interfaces are winners in such situations. In this case, vehicle is close to the hierarchy graph than engine to a car object, and hence it gets picked up by the compiler. So the third rule says resolving explicitly by overriding the implementations in the class. So if there are any conflicts, it is up to the developer to resolve them by providing an implementation directly in the class itself. We have already seen this in action by using super method or providing individual implementations. So to summarize, if a class provides an implementation, it will be the first choice by our compiler friend. If not, the second rule makes that the sub-interface more specific to the method implementation will be considered. Lastly, it's your own implementation that would take precedence over everything else. So in this session, we have learned about multiple inheritance because of the Java 8 interface having default method implementations.